starting my recording. So today we're going to move into section 6.5. It's all about properties of logarithms. I'm going to do more of this tomorrow, and it's just because it's such a massive section and it's so different in terms of manipulation that you just need kind of 2-day exposure to it. So we'll do it today and we'll do more of it tomorrow, kind of hitting what's on that R4 review at the same time. So I did email out my notes. I don't know whether you caught that or not. But there are some properties, you need to know them, and you need to know them immediately. So the quicker you use them and get used to them, the easier they will be for you. So I'm going to write them on the board, and then unfortunately I'm going to have to erase them. But we need them down. They are numbered, but they're only numbered just so we can communicate about them. They don't actually occur in any order, but they are numbered. So we'll go back and put our basic definition from yesterday. So we saw this yesterday. That the definition of the logarithm is that y equals log base a of x if and only if, meaning that it means the same thing, that a to the y is equal to x. And again, this is how we translate between the two different forms. They are the same expressions, just written in two different languages, a logarithmic language and an exponential language. Okay, so now we're going to come in and list the actual properties. So in case you did not print it out, this is what they are. So our first property we saw yesterday, log base a of 1 is equal to 0. And then I'm going to ask why. For most of these, I can make them make sense to you. You can see where they're coming from. Not all of them, but most of them. If we switch forms, then this would be the base of a raised to the 0 power, which is equal to 1. And we know that's true. Any number raised to the 0 power is 1. So log base a, any base you want, of 1 is always going to be equal to 0. So the log of 1 is 0. And you can test that on your calculator. Your calculator will tell you that. Okay, number 2 says log base a of a is equal to 1. And again, why? We'll do the same thing. We're going to take the a that is the base. We're going to go across the equal sign and pick up the 1. And set it equal to the argument on the inside, which is also a. Well, sure enough, a to the first power is equal to a. Also makes sense. We saw that yesterday. I think we did log base 8 of 8. How about log base a of a raised to the r power? Well, that's equal to r. Same question, why? Do the same thing again, go to exponential form. So we'll pick up the base, we'll go across the equal sign and pick up the r, and set that equal to the argument on the inside, which is a to the r. So again, a to the r equals a to the r. Well, that's a true statement. The left and right side are the same. So what this is really saying is anytime the base and the argument are the same, you're left with the exponent. So the answer over here is just the exponent. So again, these are the answers. Number 4 is our power property. It says if you have log base a of m raised to the r power, we can bring that r out in front and write it as log base a of m. So this one's really powerful, and I call it the power property. We will use it quite a bit. It lets us do a lot of things. So the power property. So you can take this power and move it out in front. Now this one's a lot harder to make it make sense to you because I have to use like a dummy variable. So if we come in and let the whole thing equal an n, then a to the n is equal to m to the r, and now you have problems about where things are the same and so forth. So I kind of need Calc 2 behind me to be able to explain this one. So notice I didn't really try to explain it too much because we need more math behind us before we can see the reasoning on it. But we can see that the exponent comes out in a lot of these places in terms of things, so it kind of makes some sense. Okay, and then I ran out of room, so, which I knew was going to happen. That was number 4. So number 5 on my list says if you have a base of a and you raise it to a log as an exponent, so a raised to the log base a of m is equal to m. You look at that and say, well, that makes no sense at all, but it does, because an exponent and a log are inverse functions, and we know that if you compose a function with its inverse, then plug something in, you're going to get back that as the output. So this is simply saying that if we plug in an argument of a into a function and its inverse, an argument of m, into a function and its inverse, the result is that m. So that does make some sense. We don't use that one very often in our class. It does get used a lot in a calculus course, but not for us. Property 6 says if you have the log of a product. So if I have log base A of m times n, so the log of a product, then that's the same thing as log base A of m plus log base A of n. So if I have a product, I can rewrite it in an expanded form as a sum with a plus between them. And this makes some weird sense to us because we know that this is in form an exponent, and when you multiply bases, you add their exponents, so it kind of makes a little bit of sense. Number 7 is hand in hand with that one. If I have log base A of m over n, so now I have a quotient, then I can rewrite that expression as the difference of two logs. So log base A of m minus log base A of n. So when you have a quotient, you write it as a difference. When you have a product, you write it as a sum. So, and then finally, I threw on there a number 8, just so that everybody's okay with this, just to recognize that log base A of 0 is undefined. Because how do I take A, raise it to some power, and end up with 0? I can't. So this is not possible. So this ties into what we did yesterday in terms of both the graph and finding the domain. So our graphs never crossed the x-axis unless we were shifting it left and right. I'm sorry, never crossed the y-axis because we were shifting it left and right. So you can't ever equal 0. And then you also can't take the log of a negative number. So how do you take A, raise it to some power, and end up with a negative? You can't. So again, those are your log properties. There's also something called the change of base formula listed in my box, and we'll talk about that later. But there's all 8 properties, and now what we're going to do is just start using them. So we have a bunch of examples to work through. Practice here is the key more than anything else. So example 1, part A, and the directions simply say use the property to find the exact value. Do not use your calculator. So we have log base 2 of 2 to the negative 13, and I want to know what that's equal to. So yesterday when we did these, we used a dummy variable n and set it equal to using that n, and then manipulated it into exponential form. Today we can use these log properties and skip that step, which is really nice. So we're going to pay attention to the fact that the base and the argument are the same. So the answer is just the exponent. So log base 2 of 2 to the negative 13 is just equal to negative 13. So again, these guys are undoing each other. You're left with that. So does that make sense? Do you guys remember doing this in 101, I hope? Yeah. Is at the tail end of it.
Kind of.
Kind of, yeah. We'll do it a little bit more in depth here. The next one says the natural log of e to the square root of 2. Okay, well, I'm going to translate that because we just don't have enough exposure yet. I need to remember that ln stands for log base e of e to the square root of 2. And now I'm right back in the previous problem. The base and the argument are the same. So the only thing that's left is the 2, the square root of 2. What if we have part C, log base 8 of 16 minus log base 8 of 2. So log base 8 of 16 minus log base 8 of 2. I have 2 different terms this time. So what I'm going to do is recognize the minus between them. Lets me use a property and rewrite that as a quotient. So log base 8, and then I'm going to have 16 over 2. So the argument becomes a single term of 16 divided by 2. Well, I'm not done yet, but is everybody okay with that? And that was property number 7 that we used to combine those together. Well, 16 divided by 2 is 8. So I have log base 8 of 8, and we know that when the base, the argument are the same, you're left with the exponent. In this case, the exponent is just a 1. So log base 8 of 8 is 1. And part D on that one says 3 raised to the log base 3 of 5. So 3 raised to the log base 3 of 5. Okay, so this is that odd property that we hardly ever use. It was property number 5 on your sheet. So again, the exponent and the base on the logarithm are the same. So we have a 3 here and a 3 here. They undo each other, and you are left with just the 5. Any comments or questions about that?
I'm okay.
No. Okay, and again, the more of these that you do, the better off you're going to be. So practice, practice, practice. I assigned some, but you can always go to the ebook and find section 6.5 and find more of them to practice on. So, example 2 gives us information. It says, suppose that the log base A of 2 is equal to 0.3456. Now, I have no idea what A is, so there's no way for me to cheat and use my calculator. They're giving me information about log base A of 2. They're also letting me know that log, I don't know why I did that. We don't capitalize that word. Log base A of 3 is equal to 0.5298. So that was given. We want to use the properties of logarithms to find each of the following. So part A is asking me to find log base A of 6. Well, I don't know what A is, so I can't do anything on my calculator in terms of it. What I do know is that 6 is really 2 times 3, so it's a product. I can rewrite the 6 as a product of 2 and 3. And why did I use 2 and 3 versus 6 and 1? Because they gave me information about the log base A of 2 and information about the log base A of 3. So I'm going to try and rewrite my argument in terms of the numbers they gave me. Well, we have a property that says if you have the log of a product, you can then rewrite it as the sum of those logarithms. So it was a product on the left side. I'm going to write it as a plus between 2 separate terms on the right side. And then the minute I've done that, I can do a substitution or a replacement. I know that log base A of 2 is the 0.3456. And log base A of 3 is equal to 0.5298. So at that point, there is no logarithm in the problem at all. I've completely replaced those terms with what they told me they were equal to. And now I just have to add them together. 8. So I get 0.8754. So whatever the base is, we know that when we take the log base A of 6, we end up with 0.8754. Okay, questions or comments about that? You don't do these in that 101 text. I wish they were there because I really like them. No? Okay, good. How about, same idea. Let's do log base A of 9. So log base A of 9. So same dilemma. I have to be able to rewrite 9 in terms of 2s and 3s. Well, 9 just happens to be 3 squared. And the advantage of writing it this way is using the power property, I can bring the exponent out in front so that I have 2 times the log base A of 3. And then I'll do my replacement. So I'm going to take the log base A of 3 out of it and rewrite it with its decimal. So 0.5298. And then we just have to multiply that by 2. So we'll do 2 times the 0.59, 2 times 0.5298. And we end up with a final answer of 1.0596. So 1.0596. Comments or questions?
I'm okay.
Okay, so usually somebody asks, well, can I treat that as the log base A of 3 times 3? Well, yes, you could. You'll get the same answer because what you'll be doing is adding this number twice, which is the same as 2 times it. So either method works. It's up to you and whichever you see. Okay, log base A, part C on number 2 says log base A of the square root of 2. Well, we saw those square roots yesterday for the first time inside those logarithms. We're going to remember that that really means log base A of 2 to the 1/2 power because it's a square root. If that had been a cubed root, I would have written a 1/3 up there. Then bring the exponent out in front. Use that power property first before you do any replacement. So the order of operations is very important here, and it's different from what you're used to. But again, we know to do exponents before we do anything else. So I just moved the exponent out in front. So that means I'm going to have 1/2 times, and now we'll do the replacement. We'll take out the logarithm and plug in the equivalent. So we have 1/2 times 0.3456, and that's going to give me 1.1728 if I've done my arithmetic correctly. So, and that was a radical. Part D on that problem says, how about the log base A of 3/2? Well, that's a quotient, and we have a property that deals with quotients. So that would be log base A of 3 minus log base A of 2. So log base A of 3 is 0.5298. Log base A of 2 is the 0.3456. So we're simply subtracting the two of those. And again, once you've done the replacement, the word log is gone. And I end up with 0.1842. Any problems with that? We're doing good? It seems so because nobody's unmuting. So then part E on that one says log base A of A. Wait a minute. They didn't tell me about any A's up there, but we know that because the base and the argument are both A's, that the answer is 1. So it's a trick question. And I didn't put it on there, but if I had, I'm going to add in a part F. If I'd asked for log base A of -2, that is undefined. You cannot take the log of a negative number. So just in case it's on there as a homework question, it won't throw you. I really like problem number 2. Okay, so now moving on. Examples 3 and 4 are getting us ready for next week's lecture when we start solving equations. So, example 3. Says use the laws of logarithms, that's the properties of laws of logarithms, to expand the expression in each of the following expressions. Okay, so they're going to give me an expression, and what they want me to do is to expand it. Okay, so what that means is we need to write as a sum or difference of logarithms. Sum or difference. So what we're really doing here is mainly using properties 6 and 7 from the worksheet to expand it and write it as a bunch of separate terms. Now, why we need to do this you don't get, and you won't get until Monday when we start solving equations. So what we're doing here is just the background practice to get us ready to solve equations. So because this one's written as a quotient, we know that we can expand that as log base 5 of x minus log base 5 of 2, and I'm done. That's it. I've expanded it. I took it from a single logarithm and wrote it as 2 separate logarithms. That's it. So it honestly takes longer to write it than it does to do them. That's my kind of problem. Part B on that one says, how about log base 2 of the quantity AB squared? So log base 2 of the quantity AB squared. Okay, there's no inside sign separating these, so I know that this is a product. And we have a property that says if you have the log of a product, you can rewrite it as the sum of those logarithms. So I end up with log base 2 of A plus log base 2 of B squared. And they do want you to go one more step with these. So in general, if you have an inside exponent, go ahead and bring it out. So my final answer would be log base 2 of A plus 2 log base 2 of B. And that's my final answer. So I've expanded it using the properties of logarithms. Okay, comments or questions so far? Are we feeling good?
Yes.
Yay! Okay, part C says log base 5 of the cubed root of x squared plus 1. So log base 5 of the cubed root of x squared plus 1. Well, it's a radical again, so let's take that radical out of it and rewrite it as a fractional exponent. So that's my first step to figure out what's going on. So log base 5 of x squared plus 1 to the 1/3. So all I did is I rewrote the radical as a fractional exponent. And we also know that because it's an exponent, we have a power property. So I can bring that 1/3 out in front as log base 5 of the quantity x squared plus 1. Okay, and unfortunately, at this point, I'm done. And the reason I'm done is because I have an inside sign. So because this is a sign on the inside, I have two terms. And I have no property that lets me do anything with multiple terms on the inside. I can do products, I can do quotients, but I can't do pluses or minuses on the inside unless I could factor it. So if this had been a -1, I could factor it and go from there, but it's not. So that's not factorable, I'm done. So two terms, I'm gonna add on that it's not factorable, which is the other thing that's restricting us. So part of what we have to learn here is when you can do stuff and when you can't do stuff. And again, that's practice, so. Let's see, part D on that one says the ln, which means, again, the natural log, that's a base e, of the square root of AB. Well, let's do the same thing because it's similar to this one. So that's ln, and I'm going to have AB now to the 1/2 power. And we saw in the previous example, we can bring the 1/2 out in front and write to the natural log of AB. Okay, any problem with that? But I'm not done this time. This time, because there is no sign on the inside, I can expand that as the natural log of A plus the natural log of B. And I'm going to choose to use brackets around them, meaning the 1/2 can be distributed in, or I can leave it out in front. So, and that's your final answer. So it's really, really so important that you see the difference between part C and part D in terms of what you can and can't do. It all comes down to those inside signs, pluses and minuses. So far, so good? There's one more. How are we feeling? Good?
I just have a question. So is that how we're going to answer it on the homework, is with the brackets?
Ooh, don't know. Because again, I didn't go in and play with the homework. I should have, but I didn't. So my guess is yes. Because when I look in the textbooks answers, they prefer this to this. So my guess is that they're going to want the brackets. So in other words, you try and tell me if I'm wrong, please, so that I know for next time. But it honestly should be smart enough. It's supposed to be an adaptive software. So it should honestly be able to tell the difference between these and accept both of them as answers, but I don't honestly know. It's a good question. And unfortunately, I don't know. If you were turning in written homework, I would accept either one of them. Okay, one more part on that one. So this is part E. And E says log of a to the 3rd, that's a 3, all over b to the 4th times the square root of c. So just kind of ugly looking. Okay, well, what the heck do we do with that? Well, let's take it in layers. So the first thing we're going to do is undo the quotient and the product that's sitting on the bottom. So we'll have log of a to the 3rd. And then because this b to the 4th is on the bottom, I know to put a minus out in front. So minus log base b to the 4th. And because this square root of c is also in the denominator, it also has a minus. Now I'm not done, but there's the first layer at unraveling this. So does that make sense why this one's also a minus? If you wanted to, you could have used, again, a set of brackets around these guys. You called that a plus, saying that both of those things are in the denominator. I tend to not do that. I tend to think about this as If anything's got a minus, it's from the denominator. If anything's got a plus, it's from the numerator, and that lets me put things back in the right places. So the only thing we need left to do, and I'm going to go with my original set, is move out those exponents. So I have 3 log of A minus 4 times the log of B minus 1/2, that's that square root, times the log of C. And that's what I have as my answer. So, okay, any comments or questions? So that's expanding. That's taking a single term and writing it as a bunch of terms. Okay, now we got to go the other way. So this is really the practice we need for Monday's lecture. So now we're going to take a bunch of expressions and condense or combine them into a single logarithm. This is an example. So example 4 says, use the laws of logarithms to combine into a single expression. So into a single expression. So part A, and this is what takes a while to write out, we have log base 2 of A plus log base 2 of B minus 2 log base 2 of C. Now, in order to do these problems, all the logarithms have to have the same base. So these guys are all base 2. We can't do that unless they have the same base, so it's a given. They'll be the same base. So my first pass through is going to take any outside coefficient, in this case the 2, and bring it in as an exponent. That's the first thing I'm going to do. So I'll have log base 2 of A plus log base 2 of B minus log base 2 of C squared. Now at this point, we're going to come in and concentrate on the pluses and the minuses. So if it's a positive term, it belongs in the numerator. If it's a negative term, it belongs in the denominator, because these are sums and these are differences. So that gives me log base 2, and now I'm going to go to the A is a positive term, the B is a positive term, so they'll both be in the numerator. The C is a negative term, so it's going to go into the denominator, and then I'll put brackets or parentheses around it. So log base 2 of the quantity AB all over C squared. So, and that's your final answer. And now you can see where those signs are impacting what we're doing. It's hard to see it going the other direction. Everybody good?
Yes.
Yay. Okay, so part B says 3 log x plus 1/2 log y minus 4 log of the quantity x squared plus 1. Okay, same directions. We want to combine them into a single logarithm. This time I'm going to try and do it just in a single step and see if it makes sense to everybody. So that's a log. And then on the inside, because I have both positive terms and negative terms, I know I'm going to have a fraction. Okay, so if it's positive, it goes in the numerator. So this 3 log x translates into an x cubed. This 1/2 log y is going to translate into the square root of y. So I have x cubed times the square root of y. The next term is negative, so it's going to go to the denominator. So I'm going to pick up the x squared plus 1. And because it had a coefficient of 4 out in front, I'll bring that in as an exponent on the x squared plus 1. And then I'll close everything off, and I'm done. So in one swipe, you should be able to write those answers, but be careful. Huh. See, isn't this fun? Like getting a tooth pulled's fun?
I don't think that's fun.
You don't think that's fun? Okay, fine. But I got a response. I know there are people out there. Okay, part C says log 16 plus 1/3 log 5 minus log 2. Okay, so, and just because we haven't said it yet today, just to say it, all these are the same logarithms, and because we see no base written, we know they're base 10, right? So these are all log base 10. Okay, so we're going to write the word log one time. Let's see what we got on the inside. So because we see pluses and minuses, we know it's a fraction again. So I have a 16. The 1/3 and the 5 are going to get combined together to give me a cubed root of 5. And then the 2, because it's a negative term, is going to go to the denominator. So I have log of the quantity, 16 times the cubed root of 5 all over 2. Now, because this time they gave me nothing but numbers on the inside, which is nice, no variables, I can actually come in and cancel the 16 and the 2. So my final answer is going to be the log of 8 times the cubed root of 5. So 16 divided by 2 gives me my 8. I can't go any further with this one because it's a base of 10, and neither of these numbers can be written as a 10, so I'm done. One more of this type. So part D says the log of the expression x squared minus 5x minus 14 minus the log of the expression x squared minus 4. And that just looks ugly. So I have the log of the quantity x squared minus 5x minus 14 all over the log, minus the log of x squared minus 4. Okay, they are the same base again. They're a base 10, so we can rewrite this as log. We're combining them into a single expression. So the positive term is going to go in the numerator, and the negative term is going to go into the denominator. And that's what we end up with. We're not done, but there's our first pass through. So x squared minus 5x minus 14 and x squared minus 4 on the inside of the logarithm. And why am I not done? Because I'm suspicious that I can factor these things and do some canceling. So I'm going to come in and factor each one of those. So x squared minus 5x minus 14 is going to factor into what? X minus 7 and x plus 2. Factors of 14 that subtract to 5 are 7 and 2 because the 5 is negative, the larger number is negative. And on the bottom, x squared minus 4 is your difference of squares. So that's x minus 2 and x plus 2. And sure enough, we have a common factor of x plus 2, which we can cancel out. So we're going to cancel that out. And we will end up with our final answer is log of x minus 7 over x minus 2. Actually, I don't need those parentheses anymore. But you do need a bracket around the entire thing or a parenthesis around the entire thing. And here I have a feeling that when you're typing in your answers, it's already going to have the log and a bracket there. And it will probably already have space for a numerator and stuff in the denominator. So, okay, so now we've combined. So we took multiple terms and made them into a single one. So we've gone both ways. We've expanded and we've condensed. So, okay, and then the final example really dates us in terms of technology, if you ask me. I'm betting in a couple more iterations of the textbook, the change of base formula is not even in the book. So example 5 says to use the change of base formula. That's back on the front page. Change of base formula. Okay, and what that says is this. It says that if you have log base A of m, and you don't like dealing with that base for whatever reason, you can switch that into a different base, like log base b of m over log base b of a. So the argument goes on top, the base comes to the bottom, and you're switching it to a different base. So this gave us a way of finding logarithms of 2, base 3, base 4, when all we knew were log base 10s and log base e's. So it was a way to do logarithms besides that. Now your graphing calculator does it internally on the calculations, and you don't even need the formula. But it's nice to have it, just show it, I guess. I don't know why. So 5a says we want to evaluate log base 3 of 14. So again, if I were without a graphing calculator, I would not know how to take a log base 3. What we can do instead is let's go to log base 10 because that one's on most calculators and most phones these days. So we're going to do log base 10. I don't need to write the 10. I just want everybody to see that that's what we're doing, of the 14 all over log base 10 of 3. So again, the argument went on the top, the base went on the bottom, and we're switching it to a new base. Now be careful when you type these into your calculator. Make sure you close parentheses. So literally, I'm just hitting log of 14. I'm going to close that parenthesis and then divide by the log of 3 and close that parenthesis. And I end up with 2.40 217, and it goes on. And I'm looking, your textbook has you round to 3 decimal places. Yeah, to 3 decimal places. So I'm assuming the online homework is the same. So we'll just truncate that to 3 decimal places. So when you get to your calculator, you might want to double check to make sure, yes, that's what you got out of it. So, and a long time ago, before we even had calculators, you actually had log tables, and you can still find books of these, where basically you would have had log 14 that would have given you a decimal, and log 3 and a decimal, and then you would have divided them out. So that predates me, just so you know. No, I've always had a calculator for my logarithms, not a graphing calculator, but I've had to use the change of base formula. So one more. So part B on problem 5, just to be difficult, says let's take the log base pi of 20. So this is still doable. Remember, the base just has to be not 1 and greater than 0, and it is. So I'm going to use natural log this time to show you that you can use either one of them. So we'll take the natural log of 20, and again, we're going to base e all over the natural log of pi. So ln of 20 on my calculator divided by the ln of pi, and pi is on my calculator somewhere. Oh, so the pi symbol is above the caret symbol. So natural log of pi. Yep. And that way it takes in all my decimals for me. And I get 2.61. It's 69, so I'm going to round it to 2.617. So, and that's the change of base formula. So again, it was useful a long time ago. Not as useful these days with our technology. Okay, and those are the log properties. And again, the more practice we get, the better off we are. So we will do more of these tomorrow, just so you know. You've got practice coming up for them. Any other comments or questions?
What was number 4 on our when we first started this morning? I didn't get
Property
that one
4?
down. Yes.
Okay, so property 4. Oh. Tell you, sometimes I'm defeated by the marker. I much prefer chalkboard. Okay, so property 4 said that was the power property. So log base A of m raised to the r power is equal to r times the log base A of m. And I call that the power property. Okay, any of the others that you need? No, I'm good.
I just needed that one.
Okay. Okay, so yeah, if you look at the handout there, they are also in your textbook on one of the pages. At the end of section 6.5, I think it summarizes it for the chat for that section. So they're there also. So you could possibly print out that page with the table on it, and that'll give it to you. So, but again, you need to know them. Everybody else okay?
Yeah.
Okay, that's it. We're good to go. And again, we will meet tomorrow, and we'll do more log property stuff in preparation for that R4 review to date. So have a great day. Enjoy it.
Thank you too.
You too.
Bye-bye.